Okay, in the previous few videos, we have looked at how to factor different types of expressions. And the purpose of this video is just try and maybe give you exposure to lots of different ones, expressions to factor, just so you can get practice using or deciding which strategy to use. Here's just something, and I love the textbook and how they describe the different ways or strategies to solve things, and this is just sort of a synopsis from there. First and foremost, always look for a greatest common factor you can take out. Then check how many terms you have. If there's only two terms, then maybe it's a difference of squares, something like x squared minus 9. If there's three terms, then if the number in front of the x squared, or the first term, is a 1, then we have that thing where we multiply to the last number, add to the middle number, and we can factor it from there. If we have a number other than 1 out front, like a 2x squared plus something else, then we either have to use that guess and check method or the AC method. Or maybe it's also a trinomial square, something like x squared plus 6x plus 9, where you can factor it as x plus 3 and x plus 3. Maybe it's something like that. If there's four terms, then maybe it's a group factoring situation. Regardless of which one of these it is, you always want to make sure that you factor the whole thing completely. And the nice thing with factoring is you can always check to see if your answer is correct. If it's not correct, then you factored wrong. You got to go back and fix that. But if you're checking every one of them, you'll know on a test or whenever whether you have it correct or not. So I'm just going to take you through a bunch of different factoring situations, and feel free to pause all the time and just see if you can factor it first, and then press play and see if I'm doing it right too. So here's one. I've got an expression here. It has two terms. Two terms, maybe it's a difference of squares. Sure enough, it's a difference, and I could take the square root of this side and the square root of this side. So this one's a difference of squares. Now, maybe before I do that, I should look for a greatest common factor. And this one, sure enough, I could factor 4 out of each one of those. So I have 4 and then n to the fourth minus 1. Now, this is a difference of squares, like we sort of thought. So I can rewrite this as n squared and an n squared, and then a 1 and a 1, and then one's plus and one's minus. At this point, I'm feeling pretty good with myself, but I recognize that this one is another difference of squares, so I could keep going. I'll write what I have down so far, but this is a difference of squares. So I can rewrite it, split the n squared into n and n. The 1 again splits to 1 and 1, one's plus, one's minus. And I think right here, I'm finished. Okay, that one went through quite a few. A common factor, and then one of those double difference of squares questions. More for your money. Here's another one. Oh, whoops. I had somebody plan to do that question, but don't do that. Okay, here's another one. So I have y to the 6, y cubed 16. I've got three terms. So maybe it's an a's 1, the number up front's 1. So I can look for two numbers that multiply to 16 and add to 8. So 4 times 4, that would be it. So I can split this one up into, so y to the 6th would split up to y cubed and y cubed, because when you multiply those together, you add their exponents, it would be a 6. The 16, I'm probably going with a 4 and a 4. Same sign, both positive. That would be the factorization of that. Notice that the answer of doing that one would be pretty well identical to doing this question. So these numbers are the same, it's just the y's they were messing with. Let's try another one. Oh, 4 terms. 4 terms, maybe it's group factoring. Let's try and see if it works. So I'm picking that one and I'm picking that one. So out of this one I can factor a 3x squared, leaving me with just an x and a plus 4. This one here, a 2 will come. Since this is negative, I'm going to factor out a negative 2. So negative 2x divided negative 2 is a positive x. Negative 8 divided by negative 2 is a positive 4. So here's a term, here's a term. They each have an x plus 4, which is common. So I can take that out front and rewrite 3x squared minus 2. I see this and I'm thinking, oh, is that a difference of squares? But I can't take the square root of 3, so right here is where I stop. Okay, hopefully, are you seeing how you have to take a look at each question and you have different tools, different resources to help you factor that. Two terms again. Maybe I can take a t out. Maybe I can take a 16 out. What's 16 into 40? That'd go twice. That's 25, I think. Yeah, I think I can factor out a 16t. And I'd be left with t squared minus 25. So I looked for a common factor, got one. Now this is two terms. Is it a difference of squares? Sure enough, both of those are squares. So I can factor that into a t and a t. The 25 will be a 5 and a 5. One's positive, one's negative. Again, feel free to check your answer on this. To check your answer, I would probably multiply those first, come up with an answer, and then multiply the whole thing by 16t and see if I came up with that original one. But always a good idea to check. Three terms. Okay, can I factor something out? I can factor 5 out. So I'll have 3x4 plus x squared y minus 2y squared. This is bothering me a little right here. Okay, I have a number in front in the a spot, and so this one I could go 3 times a negative 2 would be a negative 6. So things that multiply to a negative 6, I'm actually just going to maybe try and guess this one and see if it'll work. Okay, so I'll split this to 3x squared and x squared. The 2y squared, why don't I split it to maybe 2 minus 2y here and a positive 1y over there. I'm just guessing. Let's see what happens. 3x to the 4th is what I thought I was going to get, and with my 5 out there. 3x squared times y would be a positive 3x squared y. Minus 2y times x squared would be a minus 2x squared y. Again, make sure you put your variables in alphabetical order. And then finally, this one times this one would be a minus 2y squared. Okay, collecting like terms. These are both x squared y, and so this would be plus x squared y. And then I have a minus 2y squared at the end. So it looks like I guessed correctly here, because this is the same as I had up there. And so then I'd multiply this by 5, and I'm sure I would get the same thing as I started with. But my answer, the question is saying factor. So this would be my answer right there. All this stuff down here is just checking that stuff there. Try another one. Oh, great. 3 terms. So we're in this territory here. Can I factor something out? I can factor a 2 out. Or I can factor 4 p's out and 2 q's. So here I'd be left with 5 p squared plus 2 p q plus, I took a 2 out, so there's no p's either, and there'd be a q squared there. Okay, I got a common factor, did that. Now this almost looks like it's in the right order, eh? But if I go 5 times 1, that's 5. So things that multiply to 5 and 1, 2 and 2, and add to a positive 2. There aren't any. So I can't go any further. That would be my correct answer right there. Let's try a couple more. Oh, two terms, difference of squares. So I'd have a p squared and a p squared. This splits up into 4q squared and 4q squared. One's plus, one's minus. Oh, that's another difference of squares. Oh, I love difference of squares. So a p and a p and a 2q and a 2q. One's plus, one's minus, and I still have that factor out front. Okay, same kind of game with that one. Let's see if there's anything different here. Maybe just this one here you would reorder, t squared minus 49. Then you could do a difference of squares. This one, maybe let's just do this one as our last one. So it's three terms, so it's here. The number in front of A is not a 1, so I could either guess and check or try the AC method. Maybe I'll try the AC method this time. To do that, you'd multiply A times C, so 2 times 12 is 24. So things that multiply to 24 and add to a negative 11. Okay, so, oh, I've got to get negatives then. So negative 12 times negative 2, oh no. Yeah, that'd be right. Negative 12 times negative 2 is positive 24. Add them, that gives you negative 14. Now it doesn't work. How about 8 and 3? So a negative 8 and a negative 3 multiply to negative 20 or positive 24, and they add to a negative 11. Those are my numbers. So I'm going to take and replace the 11x with those numbers. So I'd have 2x squared minus 8x minus 3x. Right, I split that middle term, plus 12. Now I group factor that one and that one. I can factor a 2x out of that, leaving me with an x minus 4. This one, there's a negative out front, so I have to factor out a negative, and it looks like 3 is the greatest common factor. So this divided by negative 3 would just be an x. 12 divided by negative 3 would be a negative 4. Again, this and this are the same, so I can proceed. They're common to both terms, so I'll factor it out front. And if it's out of here, I'll be left with a 2x minus 3. Again, great idea to take this and check to see if if you come up with that original answer. I think you do in this one, so that would be the correct answer. Okay. Factoring takes lots and lots of practice, and so I'd encourage you to do lots of questions just so that when you look at any question, whether there's 2 terms or 3 terms or 3 terms with common stuff in them or whatever they are, that you have the strategy and you know what to do in order to start factoring.